In the tapestry of human history, few figures stand as boldly as Archimedes, a polymath of unparalleled ingenuity whose contributions to science, mathematics, and engineering still reverberate through the corridors of knowledge millennia after his time. Born in the bustling city of Syracuse, in the heart of Magna Graecia, around 287 BCE, Archimedes emerged from a rich intellectual landscape that had already borne the fruits of great thinkers like Pythagoras and Aristotle. Yet, amidst this constellation of luminaries, Archimedes shone with a brilliance uniquely his own, pushing the boundaries of understanding and laying the groundwork for centuries of scientific inquiry. From his earliest years, Archimedes displayed an insatiable curiosity and a precocious intellect. Raised in a family of scholars and artisans, he inherited a deep appreciation for the pursuit of knowledge and the beauty of mathematics. His father, Phidias, was an esteemed astronomer and mathematician, while his mother, believed to be a descendant of the noble lineage of the Hieron dynasty, instilled in him a sense of civic duty and moral integrity. One of the most striking aspects of Archimedes' work was his ability to bridge the theoretical and practical realms of science and mathematics. In the annals of mathematical history, Archimedes' legacy is immortalized through a series of seminal works that laid the groundwork for countless mathematical principles and techniques still in use today. Among his most renowned treatises is On the Sphere and Cylinder, in which he investigates the mathematical properties of spheres and cylinders, including the calculation of their volumes and surface areas. This work, composed in the form of a letter to his contemporary Disitheus, elucidates Archimedes' method of exhaustion, a precursor to integral calculus, which he employs to rigorously derive formulas for these geometric shapes. Additionally, in the method of mechanical theorems, Archimedes presents a pioneering approach to mathematical problem-solving. Employing techniques akin to modern differential equations and infinitesimal calculus to solve a variety of geometric problems. This groundbreaking work not only showcases Archimedes' mastery of mathematical reasoning but also foreshadows the revolutionary developments in calculus that would emerge centuries later. Another cornerstone of Archimedes' mathematical oeuvre is the measurement of the circle, in which he explores the properties of circles and develops methods for approximating the value of pi. In this treatise, Archimedes employs a geometric approach known as the method of inscribed and circumscribed polygons to establish upper and lower bounds for the value of pi, laying the groundwork for subsequent advancements in the field of calculus. Moreover, On Spirals, Archimedes delves into the properties of spirals and their applications in mathematics and physics, demonstrating his keen insight into the interplay between geometry and mechanics. Central to Archimedes' groundbreaking contributions in hydrostatics is his eponymous principle, famously known as Archimedes' principle. This fundamental principle, articulated in his seminal work, On Floating Bodies, revolutionized our understanding of buoyancy and the behavior of fluids. Archimedes' principle states that an object submerged in a fluid experiences an upward buoyant force equal to the weight of the fluid displaced by the object. This seemingly simple yet profound concept provides the basis for understanding why objects float or sink in a fluid and has wide-ranging applications in various fields, from shipbuilding to the design of submarines and hot air balloons. Archimedes' principle not only elucidates the mechanics of flotation but also has practical implications that extend far beyond the realm of theoretical physics. By quantifying the relationship between the weight of an object and the buoyant force exerted by a fluid, Archimedes provided engineers and scientists with a powerful tool for designing and optimizing structures to achieve desired buoyancy characteristics. Moreover, the principle has profound implications for our understanding of density and volume measurement, as it allows us to accurately determine the volume of irregularly shaped objects by measuring the buoyant force they exert when submerged in a fluid. Thus, Archimedes' principle stands as a testament to his enduring legacy as a pioneering thinker whose insights continue to shape the course of human progress. But it was perhaps in the field of mechanics that Archimedes made his most enduring contributions to human knowledge. His seminal treatise, On the Equilibrium of Planes, laid the groundwork for the study of statics and dynamics, introducing revolutionary concepts such as the lever, the pulley, and the center of gravity. These principles not only revolutionized the construction of machines and structures but also paved the way for the development of modern engineering and technology. The principle of the lever, a cornerstone of classical mechanics, expounded in his treatise On the Equilibrium of Planes, elucidates the fundamental relationship between force, distance, and equilibrium in mechanical systems. According to this principle, the balance achieved by a lever is determined by the product of the force applied and its distance from the fulcrum, with the total clockwise moments being equal to the total anti-clockwise moments when the lever is in equilibrium. This elegant formulation not only revolutionized the design and construction of machines, but also laid the groundwork for the development of modern engineering principles. From simple tools like crowbars and seesaws to complex machinery such as cranes and hydraulic systems, the principles elucidated by Archimedes continue to underpin our understanding of mechanical systems and their applications in diverse fields. His famous sentence, "Give me a place to stand on, and I will move the earth," refers to this principle. Among Archimedes' myriad inventions, the Archimedes screw stands out as a testament to his ingenuity and practicality. The Archimedes screw consists of a helical surface wrapped around a central shaft, resembling a corkscrew, which when rotated, lifts water or other fluids from a lower level to a higher one. Archimedes' screw not only revolutionized the management of water resources but also had profound implications for the development of civilization. Its widespread adoption facilitated the expansion of agriculture, enabling communities to cultivate arid lands and increase agricultural productivity. Its simplicity and effectiveness made it indispensable in a wide range of other applications, from draining mines to supplying water to ancient cities and ships at sea. Moreover, the Archimedes screw played a crucial role in the construction of aqueducts, sewage systems, and other infrastructure projects, enhancing public health and sanitation in ancient societies. Beyond its practical utility, the Archimedes screw symbolizes the spirit of innovation and problem-solving that defines Archimedes' legacy, inspiring generations of engineers and inventors to harness the power of science and technology for the betterment of humanity. Archimedes' genius was seldom confined to the realm of theoretical inquiry. In times of crisis, his inventive mind proved to be a beacon of hope for his city-state of Syracuse. During the siege of Syracuse of the Second Punic War by the Roman Republic, in 213 BCE, Archimedes famously devised a series of ingenious war machines, including the legendary Claw of Archimedes and the heat ray. Among all devices attributed to Archimedes, the Claw of Archimedes is one of the most legendary, a formidable weapon designed to repel naval attacks that is hypothesized that was employed during the siege of Syracuse. This fearsome contraption consisted of a large crane equipped with a grappling hook, suspended over the city walls and capable of seizing enemy ships with irresistible force. When deployed, the Claw of Archimedes would descend upon unsuspecting vessels, lifting them out of the water and either capsizing them or rendering them vulnerable to attack by Syracusan defenders. This ingenious weapon not only thwarted the Roman navy's attempts to breach the city's defenses but also struck fear into the hearts of its adversaries, earning Archimedes a reputation as a master of siege warfare. The Claw of Archimedes exemplifies the intersection of science and warfare in the ancient world, showcasing Archimedes' ability to apply mathematical principles to practical ends. By leveraging his understanding of mechanics and leverage, Archimedes devised a weapon of unparalleled effectiveness that exploited the vulnerabilities of enemy ships with surgical precision, highlighting the pivotal role of technological innovation in shaping the outcomes of military conflicts throughout history, as ingenious inventions often proved decisive in determining the fates of nations and empires. Another of the most intriguing yet controversial aspects of Archimedes' legacy is the myth surrounding his purported creation of a heat ray, or burning mirror, capable of setting enemy ships ablaze during the siege of Syracuse. According to ancient accounts, Archimedes devised a system of mirrors and lenses that concentrated sunlight onto approaching Roman ships, igniting them and causing chaos among the enemy fleet. While the existence of such a device remains a subject of debate among historians and scientists, the concept of harnessing solar energy for military purposes reflects Archimedes' ingenuity and strategic acumen. Whether based on historical fact or embellished legend, the myth of Archimedes' heat ray underscores the innovative spirit and resourcefulness of ancient engineers in leveraging the forces of nature to gain a tactical advantage in warfare. The legend of Archimedes' heat ray has captured the imagination of scholars and enthusiasts for centuries, inspiring numerous attempts to replicate or debunk its purported capabilities. While some skeptics argue that the technology of the time would have been insufficient to produce the intense heat required to ignite enemy ships, others contend that the principle of concentrating sunlight with mirrors and lenses is theoretically feasible. Regardless of the veracity of the myth, the legacy of Archimedes' heat ray serves as a testament to the enduring fascination with his life and achievements, as well as the enduring allure of ancient mysteries and legends. Whether a product of historical fact or imaginative fiction, the legend of Archimedes' heat ray continues to captivate the imagination and inspire wonder about the remarkable ingenuity of the ancient world. It is certain, however, that during the siege Archimedes improved the efficiency of catapults and outer defenses, not only staving off the Roman onslaught for many months, but also showcasing the transformative power of scientific innovation in the face of adversity. Throughout his life, Archimedes maintained close ties with fellow scholars and thinkers, engaging in spirited debates and collaborative endeavors that enriched the intellectual landscape of his era. His correspondence with contemporaries like Eratosthenes and Conon of Samos provided a forum for the exchange of ideas and the dissemination of knowledge across distant lands. Moreover, his patronage by the Syracusan royal court afforded him the resources and support necessary to pursue his research unfettered by mundane concerns. Tragically, Archimedes' life was cut short in 212 BCE, when Syracuse fell to the Roman legions. According to historical accounts, he met his demise at the hands of a Roman soldier, while engrossed in a mathematical diagram drawn in the sand, a fitting testament to his unwavering commitment to the pursuit of knowledge until his final breath. In the annals of history, Archimedes stands as a towering figure whose brilliance illuminated the path of human progress for generations to come. His pioneering insights into the laws of physics and mathematics not only transformed the scientific landscape of his time, but also laid the foundation for centuries of technological advancement and societal development. From the siege engines of ancient warfare to the spacecraft of the modern era, the legacy of Archimedes endures as a testament to the boundless potential of the human mind to transcend the limitations of its time and soar to ever greater heights of discovery and innovation.